I can think of to review for the midterm exam, and also included in the midterm exam is those cards that we haven't gone over having to do with how to write your unknown report. So that's what we're going to actually begin with, is how to type your unknown report, what goes in each section of your unknown report, where to find a good example unknown report, and so forth. So this is the midterm review. It's for fall 2013. It meets today from 9 to 11:30. And we're first going to go over how to type your unknown report. Questions, multiple choice questions on what goes in what section will be on the test. So this will help you in two ways. One, it will help you on the test because there'll be about 4 or 5 questions, multiple choice on what goes in what section. And then it will also help you because most of you will be getting your genus and determining your species soon and begin writing your paper. So that's where we're going to begin, and excuse my occasional, not occasional, continuous cough. Still have a sinusitis thing. But anyway, first thing that I want to go over is in lab, you should be coming up with your genus. Almost everyone is finished with almost everything in lab. If you turn around and look at the backboard, you'll see there are about approximately 33 experiments that you have to have data from for the unknown report. The unknown report is one of the state requirements of the class. So if you don't pass this, even though it's only about 12% of the grade, it actually is something that you have to take an eye and repeat the class. So the unknown report is very, very important to accomplishing the requirements of the class, but it's also not so hard because it's a modular system in the fact that it will fit, your data will fit into a preconceived idea of the paper, and you really don't have to come up with much on your own. The first thing, of course, is making sure that you use your data to determine your genus. And so using the data you collect on your unknown experiment, you should remember it's not going to take many pieces of data, even though we did 33 experiments. Actually, we did closer to 41 if you count pouring the plate, streaking the plate, dots are us, purity lab, rotating the cultures to maintain log growth, and keeping them at refrigeration. You really only need your gram stain, so you know which side of the chart to use, gram positive or gram negative, your shape, your glucose, your Simmons citrate or Koester citrate, your hydrogen sulfide from the Kligger's iron, your VP, the indole from the tryptone broth, and your glucose and lactose, perhaps a mannitol. That's really all you need to get most everyone's genus. So hopefully if you stay after for lab today, and everyone's welcome to stay after no matter which class you're in, if you want to go with me and say, I'll be in this room and you can say number 16 I think is Citrobacter, and I'll tell you if your genus is right. Now, if you are a gram negative, we have the 6th edition of Bergey's for gram negatives, and there are little dots by the ones we use as unknowns. And so you can probably come up with your genus and species if you have, this minimum set of data. And at any time today, or by email over the weekend, you work out your genus and you want to confirm it with me, please do it as soon as possible because there are only a few tests that you may need to repeat. A couple people had to repeat their lactose because I have a feeling the first day of class, when I said inoculate all the media, people picked up a glucose and put it in the lactose. And there was about 3 of our lactose tests three of our glucose tests that came out negative that were impossible. But when they repeated them, they were fine. So I have a feeling a couple of people picked up tubes and put them in the usual selfish, activity. Instead of discarding them, they just stuck them in a phenol red basket over there. So if you need to repeat something, this week is it. Come up with your genus and then your species if you're gram negative. If you're gram positive, you're going to have to get the 8th edition of Berkey's and look up your genus in the back of the 8th edition of Berkey's. And under that genus, there should be 3 to 5 species. And you will then match your data to those species and see which one is the most likely. And again, email me or see me and say, number 16 I believe is Proteus vulgaris or Proteus mirabalis or whatever you determine your species to be. Remember, you can't write your paper till you have your genus and species confirmed. Now, once you get your genus and species confirmed, go to the website and go to where it says Comprehensive Final Exam All. Click on that button, and then it says at the top, how to type and write your unknown report. So click on that menu item, and there are several things to talk about here. One, when's it due? It's due the last day of class. While you're taking the last chapter test on the last lecture day of class, I will be grading your unknown report. And when you turn in your unknown report, don't put it in a plastic cover or anything like that, just staple it. I know plastic covers look nice and it makes it look very professional and all that, but it's very hard for a teacher to carry 60 plastic covers. They're like ice. So just staple it with a title page and turn it into me. And the best way to do that is to bring it into that class, the very last class of lecture. And while you're taking the Scantron test, I will pre-grade it. Now, pre-grading gives people an idea that they can get another grade. This is your final grade. What it does is it guarantees you that if you meet the minimum criteria for turning in a paper, then I will tell you what few 4 or less things you have to do to make that paper a 90 or above. It doesn't mean that you take a piece of craft where you've scribbled on a whole bunch of papers and put handwritten notes in there, staple it together, and call it a first draft. It is not that. This is the grade you're going to get. Now, when you turn it in to me, I will write on the cover or title page, you will get a 93 if you do the following things that need correcting. And I will say, page 3, paragraph 6, underlined sentence, fix, blah, blah, blah. So it will tell you what you need to do. You will then take it home, go back to your computer, and fix the little items that I told you to fix. You rip off that title page that I wrote, 92 if you do the following 4 things, and you staple it to the final draft and put it in the final exam packet that you give to me on the day you show up for the final exam. So that's the situation on how it's graded and when it's due. All right, what if it's a disaster? I have people that don't confirm their genus and write some Ebola paper for me. I have people that don't follow the format and write an English paper. There's always somebody that is in some other world. All right? There are people that identify the wrong unknown, don't confirm it, and write a paper. Don't do any of those things. But if you do, what happens? Well, if you cheat, if you have completely wrong, if you do the completely wrong format, I will write 0. on the outside of what you turn in, and I will write a little note. You have 24 hours to resubmit this to me as a Word attachment or by fax. And my fax number somewhere is down in here. All right, what if you do like me? You wait till the last minute, you suddenly realize, oh my God, I'm not going to make it. Do I skip the chapter test and get a doctor's excuse and try to, con him? And the answer is don't. Come in, take the chapter test, tell me you didn't quite finish with your paper, and I will give you to the end of the day, that midnight, to get it to me as a Word attachment without a deduction. If you are too far behind for that, I have actually people that haven't collected their data by that day, that still have tubes in the incubator.
Oh.
If you're one of those, this will apply to you. And that is, take the deduction for a late paper. It's 25% per day.
Wow.
So, I wouldn't want to take more than one. If it's due on a Thursday, and I give you to Thursday midnight, and you take Friday, that means the highest you make is 75. But if you do that, remember, fax or email it as a Word attachment. Now, let's talk about what is cheating and what is not. If you get a paper from a previous student from a previous term, beware. Every term, we do slightly different tests. So if you said we did the peptone iron this term, I know you cheated, because we didn't in any class. Last term, we didn't do litmus milk. So if you leave it off because we didn't do it, we did it this term. Each term, we do slightly different tests. And each term, one test doesn't work. But guess who knows which test didn't work? I do. So if you say it worked, and I know it didn't work for anybody, that's cheating. How do you prevent cheating? Write down exactly what your results are. Don't put down any test you didn't do. And don't write down what you think the result should be, but exactly what you got. If your MR was supposed to be positive and it was negative, you write down what you got. You can explain it away, but you can't explain away that blah 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 test didn't work this term. Like last term, clickers didn't work. I had people telling me that their clickers glucose was positive. Nobody got anything on clickers last term in hydrogen sulfide. Yet people were telling me they got a hydrogen sulfide positive. So don't cheat. Don't put down any test that you didn't do. If the media was missing, don't worry about it. Just say urea was out by the time I got to it. There's a rolling chair here. All right, so that's about how to turn it in and what to be careful for. Also, when we get to the data page, you're supposed to have 3 data references. So you're supposed to have, grab one of these. Yeah, it's fine, wherever you want to sit. Yeah, you can pull that one out, or you can pull this one along the side, whatever you want. Just tell this girl to move over. Give a little space. Another problem that I do have on these is people exaggerating their test results. If you look in this book, and it only gives 6 results where you're unknown, you only put 6 in that column. You don't just make up stuff to make it look good because it fills all the spaces in the column. You only put what you got. Remember, I've been doing the same 30 unknowns for 25 years. I have them memorized. When you make up results, it's not going to go well. All right, another key thing, and when we get to the data page, you'll see this, is when we talk about recording your results, don't record Kliger's iron positive. There is no Kliger's iron in any of these reference books. They use the basic test. So when you're putting in your data chart, Kliger's iron slant deep, remember, there is no result for that in the column. I mean, what you're going to do is you're going to put the glucose, and you're going to put gas from glucose. You're going to put the lactose and the hydrogen sulfide gas. Then you will have a result for each one of those. And for litmus milk, there is no positive. There is lactose and casein. On hectoin, there is no result for hectoin. There is lactose, hydrogen sulfide, and a color on agar. The color it grows, whether it goes green on agar, or clear on agar, or turquoise on agar, which tells you Shigella, Salmonella, or lactose negative. Let's see, what others? EMB. There is no result for EMB. It's lactose, and whether or not it's a gram negative or not. Let's see. So remember, there's a lot of these that the actual test, that's the name you put on your chart, is not what you're going to find in this book. What you're going to find in this book is the pieces that are in that test. Okay, so let's talk about what goes in each section and things like that. And the best way to do that, down here I put what goes in each section and how to type it. And I'll briefly go over that, but it's better to actually look at a paper. So the first section is the title page, and remember the title, we don't want you to write anything intelligent. Nothing interesting. We want just the facts. Unknown number 6 was identified as Proteus vulgaris. Our Proteus vulgaris was identified as unknown number 6. That's the only title. That's it. Don't be making something fancy. Alright? And then on the title page, even though it's not APA style, this is just for turning it in, you have to put your last name first, your first name, your section number, your class number, the term, the college, the date, your phone number, and your email address. All of those go on the title page. Why? If I get it on the final exam that day, I compute your grade. And when I compute your grade, if there's a question about something on the paper, I want to be able to contact you within a 2-hour period because I have to give you a grade. And if there's a question, like when you made a copy of your final draft of your unknown paper and you put it in your final exam packet and you left off the reference page, do I want to give you an F, or do I want to find that reference page and give you the grade you deserve? So I want to be able to contact you on the day I grade the final exam. So that's why I want your phone number and your email address on the title page. The abstract is a summary of the paper that can stand alone. Back in the days before Google and all of these things, libraries had books of abstracts. And so we would have every month a magazine come out, a journal come out, and it would have latest papers in microbiology abstracts. And you would read the abstract, know what the person got in results and what they were doing, and then be able to order the complete paper. So an abstract is something that can stand alone, and you can type it one of two ways. You can type it on a page completely by itself, directly in the center, squared and justified in all margins. It is perfectly squared and justified in the exact center of the page with the word abstract above it, centered on the page. Or you can type it above the introduction as a square indented, where the introduction follows it double-spaced. And the abstract is single-spaced, justified in a square above it. If you type it above the introduction, you do not have a title, you do not have the word abstract, and you do not have the word introduction here. They sit free like that. If it's typed on a page by itself, it must be squared in, justified. It can be double or single spaced, and it must have the word abstract. But it must be 7 to 10 spaces in from all margins, squared in the center of the page. All right, sorry, this is called APA or MLA style. It's from the American Psychological Association. They wrote a manual on how to type dissertations, journal articles, master's thesis, and articles for newspapers. And they wrote a book on it called the American Psychological Association APA Guide to Writing Term Papers, Dissertations, etc. Once they did that, all the rest of the science world decided to adopt it instead of everybody writing their own. So ours is slightly different than theirs, but we use the APA style manual, and when you get admitted to medical school or nursing school, everything you turn in must be typed APA style. And they will hand you an APA manual, publication manual, and they will tell you on the first day, read this, about that thick. Anything you turn in for homework while in nursing school must be an APA style. If you turn it in and it isn't APA style, you didn't turn it in. And just to let you know, the little old ladies in the nursing school will actually go and get a ruler and measure your margins. And if your margins aren't what APA style says, you didn't put it in the paper. So I am not picky compared to what nursing school is going to be like. Everything you turn in must be APA style, and they will actually measure the margins. All right, so that's abstract. Introduction is typed double-spaced. It is indented for paragraphs. And key thing, in the introduction you must have something about the scientific method, coaches' postulates, universal precautions, and why we do unknowns. You do not mention anything about your unknown. It's an introduction that's explaining why we're doing this paper. So you would say something, you can read several of them that I have online, but you would say something like, we do unknowns to prove coaches' postulates. Coaches' postulates allow us to identify the type of bacteria that causes a certain disease. Then you would probably quote coaches' postulates just so you get your nice little quote in your paper. And you'd say, the reason we quote coaches' postulates and we identify unknown diseases is that once we know the causative agent of the disease, we can treat and cure the patient. And when we're doing these exercises, we maintain purity and log growth by refrigeration and subculture. Don't forget that. And that we protect ourselves from the microbe and us from contaminating the microbe by using the incomplete universal precautions, which are, and you talk about your, locking the door when microbes are out, no food or drink, wearing gloves and a smock, that you heat your loop and cool your loop so that you don't carry over contamination from the atmosphere and the environment. It's just a little discussion of why we do unknowns and how we do unknowns. Nothing about your unknown particularly is in there. Nothing about, if yours is Proteus mirabilis, nothing about it in the introduction. Then the next is called the methods section. And there are 2 legal ways to type it. One of them, I beg you, in all that is holy, please don't do it that way. Just do a table. The other way to do it is a narrative story. On October the 3rd, I received my unknown, period. I melted an auger, I poured a plate, cooled it, and streaked with the following pattern. I incubated it at 37 degrees overnight. I obtained the plate and numbered the dots. Blah, blah, blah. You go on, and I actually had someone do this. Look in this room here and see if you can find a chair. Right there. Yeah. So, anyway, I did have someone do this once. It was 40-something pages of everything they did during the entire experimental process, and it drove me nuts. And after the 3rd page, I wrote, I'm not reading any more of this crap. So, please put it in a table, and I'll show you how to do that. The next section is data, and it is also a table. And I'll show you how to do that in just a moment when we get to the example paper. And then the section 6 is the conclusion. And the conclusion is the only thing that's difficult in the whole paper. And there are specific things that go in each paragraph, so write yourself a little note. The first paragraph is a word story of the dichotomous key. I received my unknown on November the 3rd. I poured a plate, I streaked for isolation. I did the dots for us lab and the purity experiment. I determined I had a gram-negative rod that was glucose positive. In further experimentation with my Simmons citrate, I found I was Simmons citrate positive, and with my Clicker's iron, hydrogen sulfide negative. My Vokes Proskauer broth was negative, and therefore my genus was Proteus. And then you reference the website that contains this. So the first paragraph is a word story of the dichotomous key and how you determined your genus. That's easy. All you have to do is read the dang key and put it in words and make a reference. The second paragraph is what's hard. It's how you determine your species. So you're going to have to say, if you got the 8th edition, I looked up the genus in the 8th edition, and under it I found the following species. And you list the species. And then you say, using my data, I determined the only significant difference between the species of Enterobacter aerogenes and Enterobacter cloacae was motility. Mine was motile, and therefore I determined my species to be cloacae. And then you reference this book. So that is really the only difficult in the whole paper to write, was how you determine your species. Do not list 52 tests. Only the 1 or 2 or 3 tests that differentiate your species from the other ones. The third paragraph of the conclusion is called the excuse paragraph. Why you got results that no one else on earth has ever gotten. And I'll show you how we determine this. You look in all your reference books, and if the reference book, your reference book says that your hydrogen sulfide was positive, and no reference book, you can use this, see, no reference book says, here, try this. No problem. No reference book that you look at ever shows that it has a positive hydrogen sulfide. You're going to have to tell me how you got such a thing. And it's easy. If you got a positive and no one else has ever gotten it, there's only 3 reasons. One, the most likely, 99% of the time, you accidentally contaminated the experiment. Either your unknown was contaminated, or in the process of doing the experiment, you got something from the air in there that gave you this positive result that no one else has ever gotten. And then you can say something like, well, it is unlikely, but possible, that mine was a mutation. Remember, mutations don't happen very often. Now, what if you got a negative and it was supposed to be positive? That's also fairly easy to explain. One, your unknown was dead when you inoculated it, or the loop was too hot and you did it wrong and there wasn't enough to repeat it. Or you were contaminated. Or the media was made wrong. Like this term, one of our media was made wrong. Nobody got a positive on it. So, you know, I know that if you say you got a positive, you either read it wrong or you cheated. Or, you know, some other thing. So remember, if you got a negative and it was supposed to be positive, then most probably your unknown died in the refrigerator. You didn't subculture it early enough at 10 days, and you waited to 14 days and it was dead by the time you did it. Or you heated your loop too hot, picked up your unknown and killed it when your loop was too hot. And when you inoculated it, of course, nothing's going to happen with a dead unknown. The third reason, again, is the media was made wrong or out of date, or there was a problem with the reagents. And that happens. Remember, you're hypothesizing most common things that it could have given you a false result. That's why we call it, I used to call it the funky results paragraph. And then I had a person write, my funky results were. Don't write the word funky in any term paper. Alright, so again, the third paragraph of the conclusion is the excuse paragraph. Funky results, you explain away what could have gone wrong. You hypothesize. The fourth and subsequent paragraphs of the conclusion are interesting information about your unknown. When you open Bergey's manual, it will tell you that this was first named in 1925, and the person who named it was Kirchner, and it's normally found in the soil. So these are interesting pieces of information. Your antibiotic results, your antiseptic or disinfectant results if you did that experiment. These are interesting results that you put in the fourth paragraph. Note, in the fourth paragraph of the conclusion, you must relate your bacteria to a pathogen. That's in the state guidelines. You must say, well, the reason he gave us this unknown of Shigella enteritis is that Shigella is related to the Shigella that causes human dysentery and horrible human diarrheas. And this bacteria that I have identified is related to, in the same genus but a different species, so that we know what this bacteria looks like and tastes like, even though it is not a human pathogen. You must relate your bacteria to some closely related pathogen of humans in the same genus. You can Google it. You know, you can just say, human pathogens, genus Shigella. And then it will give you a couple of, and you can just write yourself a little paragraph there. All right, references, they're typed very strangely in microbiology and APA style. First of all, they're by author's last name and alphabetized. They are not numbered. And I'll show you on the paper about that. So let's go to the paper. Excuse me. Example report. So here is an example paper. Unknown number 7 was determined to be Klebsiella pneumoniae ozoni by last name, first name, college, ID number, class, section, date, phone number, email. Title page. Anyone have a question about the title page? Next, abstract. This person put it on a page by itself, and of course, because this is formatted for the internet, it's not quite squared in like it should be. It should be like this. Notice it's justified. And you just put, unknown number 7 was received on November 9th, the street plating pure culture was performed, blah, 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 blah. And he talks about all, maintaining the log growth. And then it says the following tests and procedures were performed on the organism colon. And then you list all 33 tests you performed with the results after the test in parentheses that you got. It's the world's longest run-on sentence. English teachers fall on the floor and froth at the mouth. We don't care, it's not English class. All right? This is the way we do it. We don't want anything interesting, we want just the facts. All right, once you list all your tests, then you say, using the dichotomous key, then you reference where you got it, and that would be our HicksMicro blog site. I determined the genus was, and then you can go on and say, and then you list the Burgess manual that most closely represents the results you got. It may be the 8th, it may be the 6th, it may be the 7th, it may be the systematic. Whichever book results was closest to what you got. Remember, the microbes change slightly over time. That is the Burgess that you quote, and the last 2 words should be your scientific name. Unknown number 7 was identified as, and then you put Klebsiella pneumoniae ozoni, underlined. Remember, don't capitalize the species. So, anyone not understand how to write an abstract? It's very simple. Yeah?
I have a quick question. So the sheet that you gave us in class for the gram-negative rods, that you said that was from the 6th version of Burgess manual, so we could reference that when we...
You can reference that for the species, and yeah, I guess you could reference it for here if that most closely matches all your results. Yes. Okay, so that's the abstract. It's not hard to write. Now I know how you're all feeling. You're all feeling you're going to put it off to the last minute. Let me just remind you that it's much, much better to pretend the last minute is like a week and a half earlier than it really is, and to do it on a weekend before you're under pressure for final exams, and that once you get into this, you can get it done in a day. I know it seems quite a big deal right now, a lot of work, but it's really not once you get the information together. All right, so the next part of the paper is the introduction, and yes, I have people that are so in tune to cheating and copying that they cut and paste the word page break. Do not copy my paper, and do not copy the page breaks. All right? This is the introduction. The introduction is generally why we do, thank you. Thanks, guys. Generally why we do papers. And it does not contain any information about your particular unknown. And notice how we do references. We don't put any page numbers. There are no IBIDs. There are no little numbers hanging up in the air. It is just author's last name, comma, date published. The period goes outside the comma. Sorry. All right. This is just, he quoted Coach's postulate, so because you have to have at least 6 references, and he wanted to quote from his textbook so he could use it. Okay, so that's the introduction. Remember all the things you've got to put in the introduction. You've got to put universal precautions, Coach's postulates, maintaining log growth artificially with subculture refrigeration and incubation. You've got to put in there, anything I forgot? I think that's it. 6 references in the total paper, minimum. And the 6 are easy. 3 Bergies, your atlas, the website, and your textbook. Now you got 6.
What is it?
All right. How to type and put in the methods. It's a table. First thing you do is take all the tests you did and alphabetize them. That is the first column. Alphabetize the test you did. Now, this, and when they were doing this, we were doing the Intero tube. We no longer can afford it. At $75 a student, you're not worth it. So they don't do it anymore because we don't do the Intero tube. But you can see where the tests have been alphabetized. Then, this is where on the website that page is found. Do not just make up something. Go to the page on the website and look at the page address. This address for this paper is unknowncoli.htm. So you would put asterisk unknowncoli.htm, and the asterisk would refer to the bottom of the page, which would give you the rest of the address. So remember, this is the web extension. What is the web extension? Everything past the web address for the whole website. This is unique to the page. So that's what goes here. And I blotted them out because everybody copies mine. Go and look yourself. What is this column? The third column of the table is anything you did that was different than how it says on the website to do the experiment. So if it says read it at 48 and you read it at 56, or you read it at 7 days instead of 48 hours, you need to put the exceptions. So he put his exceptions here. And you can find this, it's all on the website. It's the exact same papers on the website. Here's the rest of his chart. It was supposed to be read at 48 hours, and he read it after 2 days, or 7 days, or 3 days, that sort of thing. So it's very easy. Everybody is familiar with a word processing program that has a table maker. You go in there and you say insert table. You tell them how many columns and how many rows. And then you just start typing. And it makes you a pretty little table. You should be back in the days when they first came out with Apple word processing, and we did, to make a table, we had to do spaces. And then we would print it out and find out how many spaces off it was and go back up and back it up and reprint it. You had to print out about 60 or 70 copies to get a table that looked nice. You didn't automatically put it in there and center everything. All right, the next page is the data page. the data chart, again, the good news, the same first column, the alphabetized test that you did. The second column is your results. Now this guy's name was in Cinco. Don't put his name in there. Put your name. I used to put Hicks there and people put Hicks. You have a different name than I do. So remember, the first column is every test you did. So that means the second column is there should be a result for every test you did. If you didn't do it, leave it off the chart. All right, the third column is the best book. Of all the books you looked at, 6th, 7th, 8th, 9th of Berkey's and systematic, the one that best matched your results. That is the third column. The fourth and fifth column are any other two Berkey's that closely match your results. Now he went crazy and put another one. So I took it out for your example because he was just an obsessive compulsive, seriously mentally ill student. Yeah, he's under treatment right now. Prozac. All right, so remember, if your book doesn't mention something, leave it blank. None of the books report antibiotic results, so you will not have anything in the antibiotic column. And they may not mention a result. If they don't mention it, remember, the newer the book, the less results they report. Old books are like us. They did every test on every microbe. But as the books got better, they only did the results that are necessary to identify. So by the time you get to the 9th edition, they may have only 7 results or 5. While in the 6th edition, they will have run 20 tests. One key point on this data chart is make sure you put a key to symbols used. Remember, we don't know what your little symbols mean. These little symbols mean different things to different people. Most people consider that to be 100% positive. So you have to put, and if you look in each book, they will tell you positive means 90 to 100%. Positive with a little slash underneath it means 75 to 90% positive. They will tell you what the symbols mean in the forward to the book. In the beginning of Berkey's manual, it will tell you what each of the symbols mean. There is a page right at the beginning that tells you how to use this book. And it tells you what the symbols in the charts mean. So you need to put that in there. If you're using this one from the 6th edition, YG means yellow plus gas. Acid plus gas. No change. So if you're going to use a symbol, don't leave me hanging not knowing what the heck you're talking about. Tell me what it means. So basically all you're going to do here is get 3 Berkeys and fill in the chart like you did on the library assignment, which is why we did the library assignment, and stick that in your paper. It's not hard to do other than the busy work of going and getting 3 Berkeys. And of course you can use McFadden, 3rd edition. You can use systematic. Remember, you pick the books on how close they are to your results. Conclusion, we've already discussed. Here in the red, it just tells you what to put in each paragraph of the conclusion. The first paragraph is how you got your genus. Second paragraph is how you got your species. Third paragraph is things that went wrong. And then after that is other paragraphs to discuss important information, including relating your unknown to a deadly pathogen. All right, last is the references. The reference page is typed alphabetically by author's last name. It is single space within and double space between because this is done in HTML. It doesn't do that exactly. But notice since Bergey's has 23 editors, you don't put the editors in there, you just skip it and go with the title of the book. And notice only the first word in a title is capitalized. Then you put the edition, date published, where published, and then you use the page numbers in order that you use them. So if you quoted from page 355 first in your paper, that's the first page number you put there. Then if you quoted from page 12 and 566, get it? So remember, Bergey's is done by the name of the book because there's so many editors. But when you get down to your textbook, that's how that's referenced. And remember, we add page numbers. And then finally, how do you reference a website? And you put the, if you have an author to the website, then you put the author's name, and you put the title, the date it was published, the title of the website, and the hour and date that you retrieved it. And then you put the page number of the main page, the address for the main page. So if you looked at this paper and you're going to reference this paper, you would say, you know, unknowncoli.htm retrieved on November the 8th at 10 a.m. Pacific Standard Time. Remember, pages on the web change by the second. That's why you have to put the time on the date that you retrieved it, because it can change. And then the last thing, of course, you put the web address of how to find that page. Okay, so that's how to do your paper. Questions on how to do the paper? Anything about doing the paper? There's another example of a paper done here and so forth. So there are 2 examples on the website. All right, the next thing that we're going to do today is we're going to attempt, I don't know how successful we'll be, but we're going to attempt to go over some of the cards that people do not know very well. Let's see, I'm not absolutely certain that it will come up, but we'll see. Would you rather go over the cards or go over word questions next? Word questions? Okay. Is there any particular card that people don't understand? I won't ask you about the Intero tube or the oxyferm tube, except for which bacteria are appropriate for each one. So let me just go to that one. Go to, if you have your cards, turn to the oxidase test. All right, so the oxidase test is used to determine whether or not you do the Intero tube 2 or the oxyferm test. Let me just get you one. I think I have one that I can show you.
He's the best professor. Are you going to teach biology? Yeah, 'cause he's a good professor.
No, they're all gone. All right, well, anyway, this was a test where you could run about 14 tests in one day. And we usually did it the last day of class so that students wouldn't skip all those. Because in one day you can find out if you have a gram-negative unknown, what your genus and species is. And people would wait until that and then just skip all that and say they did it. So anyway, the way you do the decide interior tube or oxyperm is that if you have a gram-negative rod, they're the only ones that can be done on the interior tube. Has to be a gram-negative rod, and it has to be oxidase negative. And on oxyperm, it has to be a gram-negative oxidase positive. Now, when you do the oxidase test, you're going to find a lot of interesting information, and one of them is that if you are gram-negative oxidase positive and you're a rod, you can only be Pseudomonas, Alkalogenes, or Aeromonas. Those are the only three genera that are gram-negative oxidase positive. If you're gram-negative oxidase positive cocci, you're either Neisseria or Moraxella. And you can tell because Moraxella is a diplococci. Neisseria is a gram-negative cocci. So the advantage of the oxidase test is it kind of limits how, from 38 genera, what your unknown can be, down to 3 if you're a rod, or 2 if you're a gram-negative cocci. And of course, if you do the oxidase test in class, I believe we're using, in this class, at LACC, we have both a pink and a blue reagent. And at Glendale, we have a blue reagent. And you put the drops down an old slant, and if it turns darker immediately on the blue one, you're oxidase positive. If the reagent stays the same color, it's negative. And on the pink reagent that we have a little bit of left here at LACC, it goes from gray to pink and back to gray if it's positive. Okay, so that will be a test question, a multiple choice question. If you're gram-negative oxidase positive and you're a rod, what are your 3 choices? And that is Pseudomonas aeruginosa, which has a green pigment growing on agar. Alkalogenes, which is glucose negative, and Aeromonas. Let's see if there's another test that I haven't really discussed. Let's talk about the antibiotic disc, since everybody's doing that one. You're going to pour a plate, cool a plate, take a sterile Q-tip and cover it with bacteria. And then you're going to take tweezers and drop these antibiotic discs about 2 inches apart and leave it in the incubator upside down overnight. You're going to come back the next day and you're going to observe these zones of inhibition. And the zones of inhibition, it's these width. It is the diameter of the clearing. And you measure them in millimeters. Now, the correct place to get the number of millimeters width that's considered effective